We can also combine these. What if we wanted to take the derivative, let's say, of 2 over the cubed root of x squared? All we're going to do is rewrite this, but we have to rewrite both with fractional and with negative exponents. So still keeping the d dx, we haven't taken the derivative yet. This 2 is along for the ride, and this is x to the negative 2/3. 2 over 3 from the radical, negative because it's in the denominator. Now, just as we've been doing, we can take that derivative, bring that down, the 2 is along for the ride, bring down negative 2/3, subtract 1 from the exponent, negative 4/3 x to the negative 5/3. Then this comes back down, which is cubed root of x to the 5th. All right, there. In case it's hard to see, this is negative 4 over 3 cubed root x to the 5th. Try one on your own. Let's take the derivative of 4 and then the 4th root of x. Remember, there's an invisible 1 next to that x. Pause the video now. Okay, first we rewrite it. This is x to the 1/4. It's in the bottom, so it's negative. Now we use that command to take the derivative. This is 4, negative 1/4. X to the negative 1/4 minus 1, which we're going to write as 4 over 4. So these 4's cancel out. We have negative 1x to the negative 5 over 4. Then we bring that down. Negative. We know our x is going to be in the denominator. Remember, this isn't just something blank. If there's an invisible number in the numerator, it's an invisible 1. 5/4. That's the 4th root of x to the 5th. So at this point, we should be able to do some sample problems, putting together everything from the past couple days. Let's say we've got a function f of x that equals 3x to the 5th plus 1 over the square root of x minus 3. What we want to do is we want to find f prime of x. The first thing that we're going to do is we're just going to rewrite our f of x before we do anything involving the derivatives. So instead of putting that derivative, what the derivative equals, first of all I'm just going to rewrite this f of x. It's really important to keep your notation distinct. I'm not going to take any derivatives until I've completely rewritten it. So even though I could take this derivative immediately, if there's a rewrite step, I'm going to rewrite everything. Otherwise, what happens is that students have to partly take a derivative here and not here, and it's all over. It's a mess, and they forget to take one part, and they take another part twice, and just rewrite it first. Don't combine taking the derivative with a rewrite step. So we're going to keep this 3x to the 5th. This is x to the 1/2. It's in the denominator, so it's x to the negative 1/2 minus 3. Now I'm at the stage where I'm ready to take the derivative. And once I have this, going to take the derivative of every single term. I don't want to combine, like I said, rewrite and derivative taking in a single step. So this 3 is along for the ride. We bring the 5 down, subtract 1 from the exponent. Here, same thing. We bring the exponent down, subtract 1 from the exponent. Then here the derivative of any constant number is just 0. Now we're going to have a little bit of simplification in this step. 15x to the 4th minus 1/2. When we do this subtraction, this is x to the negative 3/2. And then we're going to do our final rewrite. This is the square root of x. This is x to the 3rd. I'm going to give you another check for understanding problem, and then we're going to go on to some of the new rules to memorize. If g of x equals 2 over the cubed root of x plus 9x squared minus 2x plus the 5th root of x squared minus 96, I want you to find the derivative of that. Pause the video now. Okay, before finding the derivative, we have some serious rewriting to do. So I want to rewrite g of x. This is x to the invisible 1, so it's x to the 1/3. It's in the denominator, so it's 2x to the negative 1/3. This is still 9x squared, negative 2x. This is x to the 2/5 minus 96. Now it's all written. I'm ready to do the derivative taking step. That's where that g prime comes in. It's now the derivative. Got 2. Bring down the negative 1/3. Subtract 1 from the exponent. For this next one, the 9's along for the ride. I bring down the 2. Remember, this is x to the 1 power, so just plain old x. Here, this negative 2 is along for the ride. This is x to the 1st power, so when I bring it down, it's x to the 0, which is 1, and it goes away. Here I bring down the 2/5, subtract 1, and then the derivative of any constant number is 0. Now what I need to do is rewrite that. Negative 2/3 x to the negative 4/3 plus 18x minus 2 plus 2/5 x to the negative 3/5. And now I need to just rewrite these, and I'm all done. Negative 2 over 3 cubed root of x to the 4th plus 18x minus 2 plus 2 over 5 5th root of x cubed. Looks nasty, but it's just doing exactly what we were doing in the previous lecture.